Hi friends, today we are going to speak about the law of conservation of mechanical energy, and we are going to prove it by using a freely falling substance. Initially, what is mechanical energy? Mechanical energy, it is the sum of kinetic energy and potential energy. The sum of kinetic energy and potential energy is called as mechanical energy. What is law of conservation of mechanical energy? Law of conservation of mechanical energy is saying the total mechanical energy of an isolated system is always constant. That is, if there is a system where there is no external force acting, that system is called as isolated system. In that system, the total mechanical energy, that is the sum of kinetic energy and potential energy, is always a constant. And we are going to prove it by using a freely falling substance. That is, over here we are having a ball. This is a ball which is at a sufficient height, and I'm going to release that ball, and it is under free fall. Initially, let's say it's at a point A, it is falling down and it is reaching a point B. Afterwards, it's reaching a point C. The point C is such that it's not at rest, it is just touching the ground. It's just touching the ground and it's not at rest in that situation also. It's just touching the ground. Then let me say this height, let it be h, and let this distance, that is the distance from A to B, let it be x. Then what should be this distance? Yes, it should be h minus x. Okay, then initially let's say we are going to find out the kinetic energy and potential energy at this point. That is, I'm writing region A. We're going to speak about the region A. Initially, let's find out the kinetic energy at region A. What's the expression for kinetic energy? The expression for kinetic energy is, we know it is half mv square. Clear? Then what's V? In this case, I could write kinetic energy at region A is equal to half mva square. This is a freely falling substance. What is the initial velocity of a freely falling substance? We have studied it as initial velocity of freely falling substances 0. Therefore, I could write Va is equal to 0. Therefore, what's kinetic energy? Kinetic energy at region A, in this case, it should be 0. Therefore, now we have obtained the expression for kinetic energy. Then, next, let's find out the potential energy at region A. Potential energy at region A. The potential energy in this case is gravitational potential energy, and we know the expression for gravitational potential energy. The expression for gravitational potential energy is mgh. Then, since it is region A, I am writing mgh. What's HA? HA is this height. That's equal to h. Therefore, I could write potential energy at region A. It is mgh. Okay. Therefore, we are having kinetic energy at region A and potential energy at region A. Then let me write total energy at region A. Total energy, as we all know, it is the sum of kinetic energy and potential energy. Substituting the value of kinetic energy and potential energy, we could get total energy at region A. It is 0 plus mgh, that is equal to mgh. This is the expression for total energy at region A. Then next we are finding out the next other situation, that is the region B situation. We are going to say about the region B. Initially, let's find out the kinetic energy at region B. As we have written over here, we could write it is half mvv square. Okay. What's VB? Vb is the velocity at the region B. The velocity at region A, it is 0. Velocity at region B, it's not 0. Then, in order to transform this Vb square, we are using the help of third equation of motion. As we all know, third equation of motion is saying V square minus U square is equal to 2as. This is our third equation of motion. And I am using this third equation of motion in A to B region. Therefore, V square, it should be Vb square, that is final velocity square. U square, it should be Va square or Ua square. What's A? In this case, the acceleration of a freely falling substance is g. And what is s? In this case, since it is A to B distance, or we are considering A to B distance, therefore that distance is x. Okay. Therefore, this equation can be rewritten as Vb square is equal to, since this is 0, 2gx. Therefore, we could write the kinetic energy at region B as kinetic energy at region B is equal to half m Vb square is 2gx. We could cancel this 2 and 2. Then finally, kinetic energy at region B will become mgx. Kinetic energy at region B. Then next, let's find out the potential energy at region B. Potential energy at region B. As we all know, potential energy's general expression is mgh. I will write mg into hb. What's hb? hb is the height up to region B. Height up to region B, it is h minus x. It is equal to h minus x. Therefore, the potential energy at region B will become mg into h minus x. Okay. Then, now we are having kinetic energy at region B. Kinetic energy at region B and potential energy at region B. Then we could write total energy at region B is equal to kinetic energy at region B, that is mgx, plus potential energy at region B, it is mg into h minus x. Expanding this bracket, we will have mgh minus mgx, and this minus mgx and this mgx will get cancelled. Total energy at region B, then it will become mgh at the region B. Then finally, let's speak about the region C. Region C. What is kinetic energy at region C? It should be half mvc square. Vc square. Then we have to substitute for Vc square. For that, we are using the same strategy, that is, we are using the third equation of motion, that is V square minus U square is equal to 2as. I am using the third equation of motion in the A to C region in this case. That is, we are applying the third equation of motion in A to C region. Okay. Then, instead of V square, it is the final velocity square, that is Vc square, minus, instead of U square, it is the initial velocity square. Initial velocity is Va square. Va square is 0. Therefore, I am writing 0 is equal to 2. What's A? A is freely falling substance, means A is g, into S, it is the distance from A to C. A to C distance is h. Therefore, we are getting Vc square is equal to 2gh. Then this kinetic energy, it will become, kinetic energy at region C will become half m into 2gh. We will get 2 and 2 get cancelled. Therefore, mgh This is the kinetic energy at region C. What is potential energy at region C? As we all know, we will use potential energy's general expression, that is mgh. We have to write mghc. hc is the height from region, or height from the ground to region C. Height from the ground to region C, that is the object is just touching the ground. Region C is the situation where the object is just touching the ground. If it is just touching the ground, height at region C is 0. If height at region C is 0 means potential energy at region C will become 0. Clear? Then we can write total energy at region C. It is kinetic energy plus potential energy, that is equal to total energy at region C, kinetic energy at region C. What's kinetic energy at region C? It is mgh. Potential energy at region C is 0. Therefore, we are getting total energy at region C is 0. Let's analyze the situation. The region C, we are getting total energy as mgh. At the region B, we are getting total energy at region B also as mgh. At the region A, we are getting total energy at the region A is also mgh. That means throughout the motion of the ball or throughout the free fall situation, the total energy is always constant. Total energy is the thing always constant. Is kinetic energy constant in all cases? No. Kinetic energy is increasing as it is moving from region A to region B to region C. Is the potential energy constant in all situations? No. Potential energy is decreasing from region A to region B to region C. But total energy is always a constant. Thus, we have proved law of conservation of mechanical energy by using a freely falling substance. What's law of conservation of mechanical energy? The total mechanical energy of an isolated system is always a constant. It can be proved by using a freely falling substance. Hope you have understood this.